Good morning, good afternoon, guys. I hope you're having a good day so far. This is, let me think, you should probably be towards the end of the week here on this one. If not, maybe the following week. We're going to be looking at assignment number 13, quadratic functions and their graphs, objective 4. I'm certainly missing you guys a lot by now. I'm sorry I'm not with you all, but I hope you're enjoying your time with Miss Escobar. And of course, Coach Taylor's still there, so you should be having fun with him. We're getting closer and closer to the end of the year. Only a few more videos, and then you're going to be done with your notes in a couple more weeks. We will describe today the graphs of quadratic functions of the form f of x equals ax squared. So we're going to look at what happens when we add a coefficient in front of the x squared. Okay, this a is called a coefficient. We're going to answer, we should be asking ourselves, what kind of transformation will we see with this function? We will describe graphs of the form f of x equals a times x squared, and I will sketch graphs of quadratic. You all will sketch graphs of quadratic functions, label the vertex and the axis of symmetry. Make sure you write this down and you're filling the blanks on your note sheet. Let's define, explore, remember transformation. So remember, we have seen transformations before that shift the graph up or down, or and left or right. So how do you think this coefficient a is going to affect? What do you think? We have already left, right, up and down. What's left? Well, we're going to see here on the next little section, okay? Left, right, up and down. The next thing that we're going to see is that these guys kind of like can flip, okay? Left, right, up, down, or flip are the transformations we're going to see. So if a is positive, our parabola is going to point upward. And guess what? If a is negative, our parabola is going to point downward. Okay. That's it. Positive up, negative down. Okay. I'm going to put a little positive here, a little negative here. So when we say point up, it means like these little arrows at the end, they're going down. And what we're going to say later, we're going to define that you're going to see in a few videos is that this is called the max. And when it's pointing up, this is called the minimum. But we're going to define that in another video. Okay. Ooh, this is going to be a short one for you all. Ooh, lucky day. I hope you guys get this one on a Friday. My favorite day of the week. Let's look at example number 1. So if you have a graph of, let's say, negative x squared. Remember, we do our table. Negative 2, negative 1, 0, 1, and 2. Always use these numbers. We substitute these into that equation. Okay. So you have negative parentheses negative 2 squared. Negative 1 squared. Negative 0 squared. Negative 1 squared. I'm sorry, I'm running out of space here. Negative and then parentheses 2 squared. So what happens is you square what's inside. Negative 2 squared is 4, but you have this negative on the outside, so you get a negative 4. Negative 1, this stays 0. That becomes a negative 1, and then this becomes a negative 4. So these are your coordinate points. 2, how can I write this? 2 and negative 4. So let's go to negative 2, negative 4. Negative 1, 0, 0. Sorry, they're offset a little bit. 1, negative 1. 2, and negative 4. So you're starting to see like, oh, that's what this dude means when he says they flip. It's still the function x squared, except every point on the graph flipped over to the negative side. Okay, that's it. It's a super simple concept. Okay, there is a part we're missing here. If, oh no, I got something on my screen. If a is like greater than 1, they start to get, I think, skinnier. Like they get closer and closer together. And if a is less than 1, like a half, then it starts to get like wide. or it might be switched. I just need you to be aware of that. I don't think we're going to see any of this on the test, but I do want you to know that if this A is actually like a number, like 2, 3, 4, 5, or 1/2, the parabola will either get a little skinnier or will get a little wider. Okay. So what I want you to do is use the table, substitute these into this equation, -2, parentheses, x is -2 and squared. Solve all of these the same way and get your coordinate points and plot them and see what you get. And remember, our vertex is the lowest point or the highest point on the graph. So that's our vertex. And that's going to equal, it's still 0, didn't change. Okay, and our axis of symmetry is also still 0. Okay, that's it for today, guys. I hope y'all get this one on a Friday. Not sure when Mr. Escobar will give it to you, but I'm sure I'm thinking about you guys, and I hope you're having a good week.